This lesson is on the properties of real numbers, and it's a whole lot of memorizing. The only way to really do it successfully is to word associate some of these words. We're going to start with the commutative property. The word commute means to change position. For example, you went from home today and you traveled somehow to school, and that's called a commute. So the commutative property you need to associate with the idea of changing position. For math, it means your numbers are changing position. So here's an example of the commutative property of addition. 2 plus 3, well, we all know that equals 5. But it'll be the same answer if you reverse the order or change the position of the numbers. 3 plus 2 is also 5. Another example for addition may be 2 plus 4. Well, what would the commutative property be for that? You write it now. Hopefully you wrote 4 plus 2. All I did was change the digits' position. Multiplication is the same idea, that no matter what order you multiply something in, you'll still get the same result. So 2 times 3 we know is 6, and we can reverse it to 3 times 2, which is also 6. So if I wrote the example of 2 times 4, you write the commutative property of multiplication. Four times 2. The associative property. Well, we need to think about this in English as well. Let's think about you. Who do you associate with? You associate with your group of friends. And that's how I remember the associative property. It means to group or grouping. Here's an example of the associative property of addition. Whoops. You will notice that if we have 1 plus 2 plus 3, notice it's in the same order on both sides of the equal sign. We will get the same answer if we group the 2 plus the 3 first, forcing us to use our order of operations and doing that part first. So 2 plus 3 is 5, and if we add 1 we get 6. Well, in the next side they reverse the grouping symbol so that we are forced to add the 1 plus 2 first. When we do that we get 3, and then adding that additional 3 we still get 6. So what the associative property says is when you have all addition, the numbers that you group together won't affect the outcome. So let's do an example. I'm going to add together 2 plus 3 plus 4. And to set up this, I will do the same thing on the right side. And for the left side, I'm going to group the 3 plus the 4. Which numbers could you group on the right side to show the associative property? And the correct answer would be to group the 2 and the 3. Now if you said that you could group the 2 and the 4, you wouldn't be wrong. You would just also be using the commutative property at the same time, since you would have to move this 4 over by the 2 in order to even group them. So this is the best answer, just using the associative property. Let's look at the associative property for multiplication. It's the same idea. We have all multiplication. We could group the second and third number and multiply them first, or the first and second, and we would still get the same answer. So in the example, they forced us to do 3 times 4 first because of the grouping symbol. That's a 12 times a 2 is the 24. Well, 2 times 3 is 6. We have to do that first, and then times 4 is 24. So no matter which way you group those numbers, you'll get the same answer. So we will do, or I'll have you write parentheses in both these situations that show the grouping or associative property. So put some parentheses in there. Perhaps you put them around the 1 and the 2 first, and the 2 and the 3 second, or reverse those sides completely. But that is what the associative property would look like. The identity property and the inverse property can be hard to tell apart. I remember them by making a picture. This picture is a person looking in a mirror or at themselves, and I think of that as someone's identity. When I try to put that into math idea, when I take a number times 1 and I see that same number back, it's the identity property. You see yourself back in the mirror. So 0 is considered the identity property of addition, adding 0 to something. So when we use an example, if I have 2 and I want to get 2 back out, and I'm using the identity property of addition, I would just add 0 to it because it's not going to change who we are initially. For multiplication, it's different because if I multiplied by 0, I would get a 0 out. So we call 1 the multiplicative identity because it is the number that you multiply another number by in order to see yourself again. So 2 times 1, the identity, gives you 2. Or x times 1 will give you x. Inverse property, I like to think of opposites. It undoes something, just like inverse operations. And so for addition, the inverse of a number is the opposite of the number. So if you have a number a plus the opposite of a, you're going to always get 0 back. 2 plus a negative 2 is going to give you 0. If I have an example of 4 plus something, and I want a 0 out, you're going to add the inverse of 4. That's a negative 4. Multiplication is different a little bit because the inverse property of addition got you a 0, but the inverse property of multiplication will give you a 1. So what do you multiply a number by in order to get 1? Well, that's this thing right here, sometimes called the reciprocal. The reciprocal can be thought of as the inverse, but it just means you flip your fraction. You should know reciprocals from fractions and multiplying by the reciprocals. So if I have 2 and I multiply it by its inverse, which is 1/2, you're going to get 1. It works the other way too. If I had 4 times some number, well, let me change that. If I had 1/4 times some number, and I want 1 back out, you would multiply by the multiplicative inverse of 1/4. Well, that reciprocal is 4. So 4 and 1/4 are inverses. Only 3 properties left. And luckily, you've already learned about the distributive property. Remember, to distribute means to hand out. So use that vocabulary to help you. And this should be familiar. If you have a number outside of a parentheses, you could add these together first and then multiply by 2, or you could multiply that 2 times the 3 plus the 2 times the 4, and you'll get the same result. An example, I'll let you finish it, is if we do 4 times 1 plus 3. You finish what the distributive property would tell you. There I distributed the 4 to both numbers inside the parenthesis. It works for subtraction too. You have multiplication and subtraction. So 2 times a 3 minus 4 would become 2 times 3 minus 2 times 4. This negative sign or minus sign here is accounted for right there. So you'll get the right answer. I'll skip an example for that because I think we've done enough of that. This next one you'll enjoy. It's the multiplication property of 0. All that tells you is whenever you multiply a number by 0, you're going to get 0 back out. It's actually a huge deal, and you're going to need to remember that for Algebra 2 for sure. And that says anything times 0 equals 0. So if you took x times 0, you already know you're going to get 0. 2 times 0, you're going to get 0. It doesn't matter what you multiply by 0. you'll end up with 0. Then you have the multiplication property of -1. And that just means you're going to get the opposite of what number you multiplied a -1 by. So x times a -1 will give you a negative x. But it's kind of important to see that in reverse because it happens a lot in algebra. You're going to see a negative number, say a -2, and you're going to need to know that that came from 2 times a -1. Another example, 3 times a -1 will get you a -3. And again, the reverse might be very helpful. If I ever show you a -4, it might help you to say -1 times 4 in whatever math operation you're doing at the moment. So those are your properties. Again, try to relate them to something that you already know. Perhaps it's an English word you already know or a picture you already know. Otherwise, they're really hard to keep straight. I understand that fully. Thanks for watching.